Hello guys, in today's video I'm gonna go over how to find the limits of the function that looks like this, like 1 raised to power infinity, and we're gonna follow some rules over here, and you'll be using this one or this one a lot. Okay, so let's go over those one by one. So let's say if we have a function f of x and limit x approaches to a gives you 0, and the second function is g of x and limit x approaches to a is equal to 0, and then limit of fx over gx as x approaches to a exist, then the limit of 1 plus f of x raised to power 1 over gx when x approaches to a is equal to this value, which is basically exponential raised to power limit x approaches to a fx over gx, or it can be written as in this format too over here. So in this case, if limit of a function as x approaches to a is 1 and limit of function g of x as x approaches to a is equal to infinity, then it will be this over here. Okay, and but most of the time you will be using either this formula or that formula directly. Okay, so other than that, we're gonna go over some standard limits of this format. So for example, the first one we got, function is 1 plus x raised to power 1 over x, and limit is x approaches to 0, and the answer to this limit is just e raised to power 1. Okay, and if instead of x it is 1 over x, and then in this case x approaches to infinity, the power is x, the answer is e again. Okay, and then we got this x is multiplied by any number. It can be any number. Okay, so 1 plus s of x raised to power 1 over x, and where x approaches to 0 is going to be e raised to power s, and when limit x approaches to infinity and 1 plus s over x raised to power x, then it is e raised to power s. So let's solve some examples, then you will see how we can use all these formulas what we have written over here. Okay, so first of all, so what we're gonna do, I'm gonna show you what kind of problems I'm gonna go over today. So these two over here, then I'm gonna go over this one, this one, this one, and this one. Okay, so let's start with the easy one, then we'll go from there. So first example we got over here is a limit x approaches to, supposed to be infinity. By mistake I wrote 0, that's fine. So x approaches to infinity and function is 1 plus 5 over x raised to power x. So this looks like this format over here. Either you can write just the answer, which is basically e raised to power whatever this number over here, this is 5, e raised to power 5, so that's the answer. Or we can use this formula. So you see it is 1 plus 5 over x, or you can say 1 plus something. So it looks like this format over here, 1 plus something raised to power something over here. Okay, so we're gonna use this and try to solve and see if that will give me the same answer like e raised to power 5. So according to that formula, the limit of this function is basically equal to exponential limit x approaches to infinity, and if I go back, so this is my fx over here. So in my case, this example, my fx is 5 over x. So I'm gonna write 5 over x times this x. Okay, so if I go back, so this is 1 over gx over here. So this value, which is 1 over gx over here, right? So which is going to be just 5. So this is my 1 over gx. So 1 over gx is going to be just x. So x will cancel out x, and limit x approaches to 0 of a constant number is just 5. So you got e raised to power 5. Either you can use this direct formula, or you can solve it using this rule over here. Okay, good. Let's go over next one. So again, this is going to be e raised to power limit x approaches to 0. We got fx, which is 3 sine x times 1 over gx. So 1 over gx in our case is 3 cotangent x. Okay, and now we need to solve this limit over the exponent. So let's do that. So we can do this. Going to be e raised to power limit x approaches to 0. I'm going to take this 3 out. 3 times 3 is a 9. I'm going to take this out over here. Then I got sine x and cotangent x. Remember, this is the identity from trigonometry. So cotangent x is cosine x over sine x. You can make a flashcard of those identities. Just remember them. Okay. So cotangent x can be written as cosine x over sine x. So these two sine x will cancel each other. So I left with e raised to power 9 limit x approaches to 0 cosine x. And as you all know, when x approaches to 0, cosine gives you 1. So this is basically equal to e raised to power 9 into 1, which is e raised to power 9. So that's how you can solve the problem that looks like this one. Let's move on to the next one. So next one is log with base 5, 5x raised to power log with base x, 5, and limit is x approaches to 5. So we need to solve this problem over here. So how are we going to do? Again, this is basically equal to, so if you remember the property of logarithm, so log a into b is basically log of a plus log of b. So we're going to use this property over here. Okay, let me write it down over here. So we got limit x approaches to 1, and my a is 5 and my b is x. So I got log 5 plus log with base 5 x raised to power log x 5. Okay, and you all know log with the same base of same number is 1. So this can be written as a limit x approaches to 1 plus log of 5 x raised to power log of x 5. And this log of base x5 can be rewritten as log base x5 can be rewritten as 1 over log 5 of x, and that's what we're going to use over here. So I got limit x approaches to 1 plus log of 5x, so that'll raise to 1 over log of base 5x. So these are again the flashcard ideas. You guys can make a flashcard if you want to remember all of them. Okay, and use them wherever it's needed. All right, so that looks like our original formula. You remember limit x approaches to something 1 plus fx raised to power 1 over gx. If I go back again, so it looks like this over here, 1 plus fx raised to power 1 over gx, and which is equal to exponential raised to power limit x approaches to a fx over gx. That's what we're going to use in this example again. Okay, so this can be written as e raised to power limit x approaches 1, and my fx is log 5x over gx. My gx in this case is this value in the denominator, so it is going to be 1 over log base 5x. Okay, and if you see log base 5x log base 5x cancel each other, gives me 1. So this is basically equal to e raised to power 1 or just equal to this exponent. Alright, I hope this makes sense. And again, I always encourage to solve more example by yourself, practice. Okay, so let's do another example. So this one is going to be a little lengthy, but we're gonna finish this one too. So we got limit x approaches to 0. They can ask you this question in many ways. It can be just stopped over here, like a raised to power x, b raised to power x plus c raised to power x over 3 and overall 1 over x. Can be in 5 by 5 and 4 letters and 4 over here. In different ways they can ask you, but I'm gonna do it in a longer way. Okay, that'll cover everything. So what I'm gonna do, I'm trying to achieve 1 plus something so that I can use my standard formula over here. Okay, so what I'm gonna do, so in this example I got limit x approaches to 0. I'm gonna add 5 over here, a raised to power x plus b raised to power x plus c raised to power x, d raised to power x plus e raised to power x, and I'm gonna subtract 5 from here, and everything divided by 5 raised to power 1 over x. Okay, and this is equal to limit x approaches to 0. I'm gonna break it down here. Okay, so that can be written as 5 over 5 plus, and I'm gonna break this 5 to 5 ones, so it can be written as a raised to, I'm gonna do it later, so let's do this first, a raised to power x plus b raised to power x plus c raised to power x, keep going, power x minus 5 over 5 raised to power 1 over x. Okay, and let's write it over here. So limit x approaches to 0, so 5 over 5 gives me 1 plus, and now I'm gonna break this 5 into 5 ones, and I'm gonna put those ones with these letters over here. So first of all gives me a raised to power x minus 1, okay, plus b raised to power x minus 1, c raised to power x minus 1, d raised to power x minus 1, and e raised to power x minus 1. So see, I broke this 5 into these 5 ones, and if I add them, negative 1, negative 1, negative 1, negative 1, this negative 1, they all gives you this negative 5 back, and divide it by 5 over here and this all raised to power 1 over x. Okay, so what I'm gonna do, I'm gonna separate it out too, and I'm gonna do it later. So like maybe we can do it over here. So again, I got 1 plus f of x raised to power 1 over gx. Remember your formula? Let's go back to the formula again. So 1 plus f of x raised to power 1 over gx. So that was my goal. So I want to make each function looks like that. So 1 plus f of x and 1 over x. So this x is my gx. And the limit of that function is e raised to power limit x approaches to 0. So going to be f of x, which is basically this, and divide by g of x. So I got a raised to power x minus 1 plus b raised to power x minus 1 plus c raised to power x minus 1, d raised to power x minus 1, and e raised to power x minus 1. Everything, and 5 is already there, and gx, which is this x, is going to be in denominator. So let me show you what I'm talking. So this gx goes in the denominator. In our case, it is x. Okay, so I wrote it down over here. So now I'm gonna separate all of these functions. I'm gonna make them separate. Okay, so e raised to power limit x approaches to 0. So this can be written as a raised to power x minus 1 over 5x plus b raised to power x minus 1 over 5x, c raised to power x minus 1 over, or let me do one thing. So let me do, I'm gonna take this 1 over 5 out. So 1 over 5, that way we don't have to write it at every place. So d raised to power x minus 1 over x plus e raised to power x minus 1 over x. Okay, and remember, this is not exponent, this is just a letter, e raised to power x. It's not exponent here. So, and from the previous limit values, you remember the limit of a to x minus 1 over x is basically log of this letter. So that gives me e raised to power 1 over 5. So limit of this first function is log a, and this one is log b, not base a, just a. This one is log c, log d, log e. Okay, and that's where I'm gonna use log property. You remember, log of a plus log of b is equal to log of ab. So this basically can be written as e raised to power 1 over 5 and log of a, b, c, d, and e, which can be rewritten as again e raised to power log natural a, b, c, d, and e raised to power 1 over 5. And you all know e raised to power log natural is 1. So this is going to be a, b, c, d, and e raised to power 1 over 5. So that's my answer. Alright, let's do a couple more, then we'll be done. Okay, so next one is limit x approaches to infinity x minus 3 over x plus 2 raised to power x. Again, my goal is to make it look like 1 plus something. Okay, so that's what I'm trying to achieve. And that's how you can solve the problem. Okay, and how we can do it. Okay, so limit x approaches to infinity. So if I add x plus 2 here in the numerator, and x minus 3 is already there, and subtract x plus 2, and I got x plus 2 in the denominator already. Okay, see, I'm gonna break it over here. So that'll give me limit x approaches infinity x plus 2 over x plus 2 plus x minus 3 minus x minus 2 over x plus 2. And you see this over here, this will give me 1. So I get 1 plus fx raised to power gx, and I can use my standard formula to solve it. Okay, so let's do that. So I got limit x approaches to infinity, and over here I got 1, and here I got plus, these two will cancel each other. I got negative 5 over x plus 2 raised to power x. And the limit of this function using the formula is e raised to power limit x approaches to infinity, my f of x, which is negative 5 over x plus 2, and 1 over gx is just x, so it will be in the numerator. And what I'm gonna do, e raised to power limit x approaches to infinity, I'm gonna bring this x in the denominator, so that can look like a negative 5 over x plus 2 over x. Can be rewritten as negative limit x approaches to infinity 5 over x plus 2 over x. Okay, so that gives me e raised to power negative limit x approaches to infinity 5 over 1 plus 2 over x. Okay, e raised to power negative. If x approaches to infinity, so this term over here, as x approaches to infinity, this term changes to 0. So 2 over infinity is basically 0. So I got e raised to power 5 over 1 or e raised to power negative 5. So that's the answer. Okay, so again, my goal is to make it look like our standard formula, like 1 plus something. That's what we are trying to achieve over here. Okay, so the last problem is the limit n approaches to infinity, 3 raised to power n plus 8 raised to power n 1 over n. Again, this question can be asked in different ways. They can change these numbers or these letters over here or this limit, but the way to solve it always same. So what I'm gonna do, I'm gonna take this 8 raised to power n out of this parenthesis. So that will gives me limit n approaches to infinity. Inside I'm left with 3 raised to power n over 8 raised to power n. Okay, I take 8 out. And over here I left with 1. And you all will be wondering why it is not 8 raised to power n, why it's only 8. Because we got 1nth root on the top of it. So basically 8 raised to power n into 1 over n is 8. So when it comes out, it will be just 8 over here. Okay, so that's what we got over here. Can be rewritten as limit n approaches to infinity. I'm going to take this 8 out, and 3 over 8 raised to power n plus 1 raised to power 1 over n. And you all know this is less than a 0. It's a fraction. That's why I take 8 out. If I take 3 out, then it will become 8 over 3 raised to power n. And as n approaches infinity, this number gonna be keep going bigger and bigger. But in this case, now we got 3 over 8, see, raised to power n. As n approaches infinity, this number keep going smaller and smaller and smaller and smaller. So that means ultimately, as n approaches to infinity, this part over here turn into 0, 1 stay the same, and 1 over infinity you all know is 0. So here we got 8 into 1 raised to power 0. Something raised to power 0 is always 1. So 8 times 1 is equal to 8. Okay, so in this kind of problem, always take the bigger number out. That way you're left with a fraction that will be less than 0. And when you raise it to infinity, it will be equal to 0 as here in this case. Okay guys, thanks for watching the video. Please share and subscribe to the channel. And please solve more examples by yourself. Practice more, then you will be good to go. Thank you. Have a good day.